Hey, what's up, guys? Welcome back. Episode 39. Pretty tired right now. I just got done playing like 2 hours of ping pong, so. And then I just ate a shit ton of food, so it's like, you get sleepy from all the food, and then, like, you did a workout, so it's like, yeah. I don't do that much nowadays, so, 2 hours of ping pong is definitely a lot for me as of right now. But yeah. Let's get into our Pokemon of the day. We got a Jigglypuff. Wow. Little Jigglypuff. A little Jigglypuff. Sounds funny. Jigglypuff song. You just want the sound. I guess we're getting the song today. Jigglypuff. That's enough. Oh. Jigglypuff. That's funny. Jigglypuff and Wigglytuff are the best Pokemon for people who's they could snuggle with one and have it sing them to sleep. Wow, it is gonna put me to sleep. Can I keep watching that? But yeah, we're gonna take a look at the stack problem. Maybe attempt something else depending on how we go. Let's attempt this one. Remove all adjacent duplicates in string 2. String S, K, duplicate remove consists of choosing K adjacent equal letters from S and removing and causing the left and right side of the deleted substring to concatenate together. We repeatedly make K duplicate removals on S until we no longer can. So I was kind of thinking, can you hold pairs and stacks? I don't know. Can you hold a pair? I guess you can. I don't know why you wouldn't. Python. Always using tuples. That's interesting. I'm trying to think how we can kind of go about this problem. So we got to remove every character here that's adjacent. So we come here, we see 3 E's, we remove that, then we concatenate the string together. We see 3 C's, we concatenate the string together. Then in this case, we see the 2 B's, we concatenate the string together. We see the 2 G's, we concatenate the string together. We see the 2 T's, we concatenate the string together. We see the 2 I's, we concatenate the string together. We see the 2 P's, the 2 O's, the 2 A's. And then I think you have another 2 I's here, and then you have the PS. This cat is so annoying, dude. I was trying to think how we go about doing this. I guess we'd use, I think, let's kind of go through this, right? So we have our string here. Holy shit, that is all. We're going to use this as our PBB, C, G, G, D, T, C, I, P, P. I can feel the cat grabbing the Ethernet cord. O, O, A. Might have to remove this cat in a second. Looks good. So, what else do we have our stack here? We append this one. I'm just gonna, when we done with it, I'm just gonna put a line through it to be append this to the stack P. Right, and we compare the top of our stack to whatever's here. You see this, we append, right? They're not the same. Boom. So now our count, I guess we could have a count too, maybe, or something, just to keep track. Or maybe we can do pairs if that's a count. Because then we'd only have one count technically. We want to have. That's right. Let's just play with it for now. So we see a B, we put a B here. Our count is equal to K. And our top value. Yeah, we need some sort of count, because if our K is bigger than 2, then we need a bigger count. So we need some sort of count. How do we figure out the count though? Would we have to append to make it more? Use a stack to store the characters. When there are K same characters, delete them. To make it more efficient, use a pair to store the value and the count of each character. More efficient. I guess more efficient means that maybe we can do it just using a normal count. Well, anyway, right? Our count is equal to that, right? So then we'd pop. Then we go to the next value. We have C. C's not the same, so that's fine. Then we'd have G. Right, then we add G. Then we pop. I'm gonna come down here. This is also our stack as well. I just don't want to keep going because we got stuff here. So then we add T. We add T. And we pop and we pop. Then we add C. We add C, but then technically we got C and C here then. So technically maybe we pop and we pop. Then we'd have I and I. We pop and we pop. We have I. This, then we'd have P, and then P. Then we pop, O, O. We pop. Then we have A and A, right? We pop. Then we'd have I, and we still have an I here, so then we'd pop, and then we'd have S. And then we'd return we'd return PS, right? That's what I'm trying to think. The thing is, it gets tricky when you store more than 3 characters. Because if you think about it, we have k is equal to 3 here. But you know, what if, you know, we get rid of, maybe we have a double A here or whatever, but what if there's an A up here? You know, that's the thing. We got to figure out a way to store the characters. I'm trying to think what's a way that we could store character. The only way I can think about it is that we got 2 monkeys. I just don't know. I don't know if we store it in pairs. But how would we even count up from the pairs? That's a thing. Okay. We're just going to start coding something and then we'll kind of go back. So, obviously, we want to make our stack. We want to do for I in range length S. We'll make a count, right? Unless you need to keep track of the count somewhere. Try and range length S. Okay. If stack and stack -1. Gotta think about this, like, if the, when do we want to append? Right? I guess we just want to I guess we can just append every time because we're going to append every single number to the loop anyway. Alright, so we're going to append char as char. Right, and then we're going to always check if the stack has something in it, and stack -1 is equal to schar. Then if there's something in the stack and stack -1 is equal to char, then we're gonna increase our count. Wait, this is not gonna work. We'd want stack and stack minus 1 is equal to S char. Stack empty and top of stack is equal to char. If stack is not empty and top of stack is equal to char. I don't know where you append that. You don't always want to append because that's not going to work. Because then we'd append here. I guess we can run the if statement first. I mean, what would we do if they were the same? Then obviously we'd stack.pop. I guess we just want to append, right? So first char. I guess we can append after this loop. We can always check first. Stack.append char. I guess if stack minus 1 is equal to char, then dude, I'm confusing myself when I'm reading this back to myself, bro. So we got a few problems that we've done. Maybe that might be a good way to start. I guess if the length of stack is equal to none, stack.append, right? And obviously we can just continue. We don't need to check anything else, right? Then in our next loop, this will get us started, right? In our next loop, we will check if stack and stack minus 1 is equal to char. Obviously, we increase the count, right? Okay. So obviously we got 1, right? Then we check the adjacent value. If stack minus 1 is equal to S char, then we would increase our value. Yes, if the count is equal to k, then we would have a while loop here, and we do while count is not equal to 0. We would do stack stack.pop constantly, right? I can say minus 1 is equal to s char, count plus equal to 1. If count is equal to k, while our count does not equal 0, equal to k. So it doesn't include this next one, so we could minus equal to 1, right? Because technically we're 1 short, right? So we'd only loop to 1. Break and nothing. We exit this iteration. If it is, we always gotta stack.append as char, and we increase our count. Otherwise, if it's not, hang on, we need an else here. Count is equal to k. Okay, then we can append stack.append as char, right? Our count does not equal 0 now. We're good. Stack.pop count minus minus, right? Else, if our count does not equal to k, then we stack.append as char. That's char. And then we increase thinger. Right? I think so. So let's just go through this again, right? If stack is equal, if stack, okay, so if the top value is equal to the current char, we increase our count, and we check if count is equal to k. Count is equal to k, then we append. So that for the count. So it's equal to k, we append, and we do our while loop, right, and continue to stop the iteration, go to 0 and start. So I think that's good. Else, if we increase the count and it's not equal to k, we append the char, right, and then we increase our count. Then we need another else outside of this, that else if the stack is stack minus 1 is not equal to s char, then we then we stack.append as char, and we make it equal to 1. This is a crazy loop right here, bro. I don't even know if this is right. This is probably so wrong, but yeah, I think that should be good. And then we return sjar. Sorry, return. What am I doing? Dot join stack. Oh, we're popping. This is the one with 3. One with 2 it works. Kind of. It does what it is. It gets to the end of the loop, right? But if we're past it, then it's not going to work. So we did exactly this, right? This is exactly what we did here, right? But instead, it's not counting properly because it can't. See how like back if you were watching earlier, the C and the C are in different spots, and then you have an I and an I in different spots. But it gets to that point, but that's why you got to keep a count somehow of the loop. But I'm not sure how to do that. I have a hell of a bad headache right now, dude. Oh, if stack is none. That's, why am I doing the length? Jesus. You saw both characters and their counts together. You're looping up. It was right here. We had to use a tuple. Python simple one-part solution. I mean, this is exactly what we're doing, so. I think my solution, it needs to keep track of a singular character, that's why it's wrong. But I just didn't really know how to do that, to be honest, using Python. But I guess we're going to learn now. So, count is equal to 0. I guess we don't need this anymore. Alright, so we have our loop here. We're going to iterate directly over the thing. I don't think we're going to really need our index value, indices. So, Jonas. Okay, we have if stack and stack -1. This references the top of the stack is 0. It's equal to char. So if stack and stack -1 is equal. So if they're equal to each other, right? Case 1, stack exists. Stack last element, and so si are equal, and the count +1 would equal k. So remove k -1 elements from the stack. Who is #1 on Leetcode? Jeez, bro. Oh, an Australian guy. Damn, bro. Joshua Chen. Dude, is there an ELO on Leetcode? No freaking way, bro. There's no way there's an ELO on Leetcode, bro. Is there an ELO on Leetcode? Oh my gosh, there is. No way there's ELO on Leetcode, bro. This is crazy. That's crazy. Damn, bro, I didn't even know there was an ELO rating on Leetcode, bro. That's crazy. Insane, bro. Anyway, my ELO's probably ass, dude. I guess you have to do contests or something. Maybe I might try one. Like, you know, why not? I don't know. One is equal to char. Stack -1 is equal to you want to pop, right? Else stacked append jar 1. Join char times count char count stack. Okay, what are we doing here? We're joining together char times the count for char count and stack. Trying to figure out what's going on here first. If stack. Not empty box. Okay, so this loops through the stack. And time char times count for char and count in stack. I just don't understand why these ones here. I don't know what this means. Why are they putting ones here? Stack minus 1 is equal to char stack minus 1, 1. Case 1. Stack exists and stack minus 1. The last element SI are equal. And stack minus 1 plus 1 is equal, okay. Access the count, but why is the count 1? Like, So each element in stack is a tuple of size 2. Yeah, I know that. Each tuple contains the index. Index 1, the count, e.g. 3. Oh, okay, the last tuple. First item. The second item, the count. Ah, okay. Oh, okay, I understand now. Okay. Okay. I understand. So this case is that, so we're accessing, this is returning just the value, right? So this case, A-N compares with char, right? So there's no zeros, we're accessing the first element in the tuple, right? So we're pretty much just comparing top of stack with char, right? Then here, we're incrementing the count here, right? So if stack and stack -1 is 0, then we're accessing the top of the element, accessing top of stack, updating value, keeping char the same, and then accessing second value in tuple, -1, 1, in tuple, and increasing by 1. Okay. Then here we're checking if the count, so returns number, e.g. 2, is equal to k. It is pop. Okay. Else we append with a new value. This is interesting, the way this works. Char nest. If stack, oh, our stack is empty in this case, so we append. We go to our else here, right? We just append char, right? Then we check our next value for char in S. If stack and stack minus 1, 0 is equal to char. Then we access top value our stack and we increment it by 1. Well, if it's equal to k, we pop. We're missing something here. We gotta need a while or something, right? Or am I tripping? I think we need a while. Oh no, we don't need a while. We don't need to keep popping because it's a tuple. Okay, let's try and run it. I think I understand. Interesting. Definitely an interesting problem. For sure. Jesus, dude. Recursion binary tree. Two empty linked lists representing two non-negative integers. The most significant digit comes first, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Again, I feel like using an array in this case is cheating. You know, you can easily loop over each thing here, add it to an array, you know, and then just like add the array together, you know. But I think that's cheating, to be honest. Shit. I just want to make sure this pushed, actually. Okay. Alright. That can go, that can go. Adding two numbers now. Okay. Bro. I think I gotta refresh this page. Okay. So I think, well, L1 does not equal none. Let's do L1 is equal to cur, while cur does not equal none. And we can do L2 is equal to cur2. And we can do while cur2 does not equal none. Cur is equal to cur.x. And let's string one. Let's do string is equal to this. Can we do? think we might need to do a string here. String 2 is equal to this. We can do string plus or equal to cur1.val. I think that's how you do it. String 2 plus or equal to cur2.val. Cur2, cur2.next. Let's print out strings. String. We're gonna do the cheating way first. Okay. Then we can do a simple over here. We can just do res is equal to int string plus int string 2. And just return res. I guess we could just do int string plus int string 2. We need to how do we return this as a array? Return for hang on, how do we I want to practice doing it this way. Where we go so God, man. Can we do is this just for strings or join? No, this doesn't turn it into a turn for shot in res. How do you do this? Turn I don't know if that actually does anything. I don't know if this works, but no, it's invalid syntax. How do you do this? I don't even know. Okay, you return here char for char in string res. Oh, we have to return type as a list node. Oh my gosh. Okay, I guess we can do that. Let's get rid of this. Let's create our dummy. Should have checked that, bro. We're returning a list node. Jesus. Created a dummy. Dummy is equal to list node 0. 3 is equal to dummy. We would return dummy.next. Then for char in res. 3.val. Is equal to dummy. Code3 is equal to code3.next. Is that how you do it? Oh, fuck. What is wrong here? It's an integer? Oh my god. We could just do so next equal to list node int char. Then we do code3 is equal to what we had. Oops. Code3.next. Dummy.next. I think that should be good. There we go. It's actually pretty fast too. Wow. Okay, now we're gonna do the actual linked list method. We're not ever actually gonna learn how to use a linked list. We're cheating constantly. Set the number 0 itself. You may see 2 numbers down. How would we do this? I'm trying to think here. I actually don't know. I'm gonna be completely honest. I actually don't know why you have to reverse this, but we're gonna add them together anyway. So okay, we go 3, 4. This is like second grade arithmetic. I don't even know this, to be honest. 5, 7. So we add these. We add 3 and 4, which is 7. 4 and 6, which is 10. So you 0 here and you carry. 2, 7, 8. Is that right, bro? I don't even know, dude. It's 2, 7, 2, 4, 3. 7, 2, 4, 3 plus 5, 6, 4. Oh shit, that's right. Okay. Okay, so that's why they use a stack, because obviously they're reversing it automatically, but I kind of want to do this just using a linked list, but now we're going to have to reverse the linked list. Oh, dude. Not again, bro. Here comes my typical reverse the linked list problem. Let's do it, bro. See if we can remember. Cur is equal to 1. Cur is equal to 0. Well, cur does not equal none. Okay, we're going to reverse linked list 1 here. Oh, 1 here. Okay. Alright, next is equal to code.next. See this, bro. Next is equal to code.next. Code.next is equal to prev. There's only 2 people online on this problem. Okay. Get back to our OG reversing a linked list, bro. Oh my gosh, dude. I guess we gotta do it till we get it. I just find it so hard, bro. Like, so difficult to reverse. Okay, 7, 2. But once I get it, bro, it's gonna feel so good. Like, 3. Okay, we have our next pointer equal to here. Right, we have our current. And I guess our prev is here. Prev. So remove this link. We made here. So now we need to make prev is equal to cur. Is equal to cur. This one changes the link. And then we make our prev is equal to cur. And then cur is equal to next. Cur is equal to next. Oh my god, I think we did it, dude. No freaking way, bro. L2 here. Cur2 is equal to L2. Prev is equal to 0. Sorry, I guess we need prev2 is equal to 0. Our cur2 does not equal none. Then we want to use our next variable. This next 2 is equal to cur2 to next. I know we don't need new variables, but you know, it's better visualization for me. Helps me understand the problem a little bit more. Prev2 is equal to cur, and then cur is equal to next, but we need the 2's everywhere. 2. Now let's I think we did it correct. I'm pretty confident this is correct. Okay, let's just ask if this is. Hang on, we don't need all that. Let's. Does this reverse L1 and L2? Oh shit, this should be none. But otherwise we're good, man, we're good. I think that's why it didn't print. Oh shit, yeah. That's why I didn't print. Ooms, 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 Nice. So now we gotta do our basic arithmetic. Gotta do our basic second grade arithmetic. Right, so I guess we can create a new dummy node. So we're only using a linked list here. Make 3 equal to dummy front. Dummy dot next. Oh. Sorry. While, yes, to approve the new head, go to L1 is equal to prev. This is for the new head. All right, then we do down here. So we want our new head, L2 is equal to prev, print prev to basic second grade arithmetic. Let's get rid of these. Start our basic second grade arithmetic. We can do while while how do we want to do this while loop? How do we implement? God, my neck hurts, bro. What the hell is wrong with me? Oh. How do we want to implement this while loop? Well, I guess while L1 and then we have to think about the out of bounds. It's going to go out of bounds. It's going to be different length. I guess we can throw the range line over there. L1, L2. Well, L1 does not equal none. Well, L2 does not equal none. Then we can. Let's keep a carry, right? In this case, our carry is equal to 0. So we do L1 L1 int 1 is equal to, let's see, wait, integer 1, integer 2. Integer 1 is equal to L1 dot val. Integer 2 is equal to L2 dot val, right? So then we add them together. So res is equal to integer 1 plus integer 2. Let me check an if statement here. If res is greater than or equal to I guess, wait, what happens if we have the carry more than, like, what happens if this was 8? Hang on. Okay. What happens if this was 8? So what if we were adding 5, 8, 4, 7, 2, 4, 3? We have 7. We'd have 12. So what we do still do 2 and then add 1. I think that's how it works. 7 and then we have 8. We have 7, 8, 2, 7. Is that what it is? 7, 2, 4, 5 plus 8, 2, 7. Oh, it's plus 5, 4. 7. Wait, did I do something wrong? 7, 2, 4, 5. So we have 9. Bro, what the fuck? How did I not get 9 here? Is it? Oh, that's a 3. Whoops. Okay. Right, so if our res is greater than or equal to 10, then technically we need to how do we do this res here? This carry, we would have to. I'm trying to think what sort of math we can use to get this number. We use 20? 20 minus 10? Mm, 20 minus 10. How we get this value, dude? I don't know how we do it. Add the digits and the carry from the previous step. The fuck? What the hell is a carry here? Oh, carry's outside. Okay. We'll add the carry as well, apparently. I have both images. I didn't think about that. Both images and carry. Calculate the new carry for the next iteration. Carry is equal to res divided by 10. Carry is in the tens place. Calculate the digit to store in the current node. Digit is equal to res. Digit is in the ones place. Creating. Bro, I do not understand that right there, but. Okay. I have to relook at this. Okay, let's relook at this. I don't understand what this is doing here. I don't get the logic here, but carry is equal to res divided by 10. And then we have the digit is equal to res percent 10. Percent 10, and we create new node, so we would do current view, sorry, cur3 cur3.next is equal to list node digit, and we've moved out pointer current3 is equal to current3.next. If the next node is an L1 and L2 if they exist. That's a good way to think about it. I realize why they have the L0 up here. It's to manage out of bounds. Manage out of bounds, yeah, because if L1 doesn't exist, then we have 0, right? Because it's none. And then over here, when we move if they exist, we would do if L1.next, if L2.next. And obviously we would return our dummy.next. That's an interesting way to think about it. Give them that invalid syntax. 9:45. Usual one is equal to L1. I don't understand what is going on here. Oh, so we've got the if L1, L0, L2. I don't know if we really need this. L0. I don't think it's gonna. Well, L1 and sorry, or L2 or carry. I think my while loop's messed up. No, there's still something wrong with it. Something wrong with the while. Am I missing the pointer advancement? Oh, geez. Oh, shit. L1 is equal to L2. Is equal to L2.next. Whoops. Summertime sadness. All my errors here. Okay, I'm not reversing properly. We got preview somewhere here. Whoops. That looks good. Oh shit, I gotta reverse it again, bro. Oh my gosh, dude. No shot, bro. Really, dude? That's in the wild. You gotta reverse again. Jeez. I mean, guess it's good practice. cur is equal to dummy.next. Prev is equal to none. Yep. While cur does not equal none. Then we want to make our next pointer next is equal to cur.next. Then we want to change our link. So we want to do cur.next is equal to prev. Then we want to update our pointer. And our pointer is, we want prev to equal cur. And then we want cur to equal next. And then we want to, I guess, return please. That works. Oh, thank God. Holy shit, dude. That was a long problem. It's probably the most lines on Leetcode I've ever wrote, dude. Jesus. Okay. I'm confused. What does this mean? I'm a little confused here, and I want to double check what this is like. Loop continues running. L1 is not none. This checks whether they're under somewhere. Okay. So L1 L2. Not none or L2 not none or carry not 0. Now what is this, dude? I'm confused about this part. This part. Can you explain? He still has used to handle the result of everything. Ah, okay. So this kind of like, this calculates the carry. And actually an interesting way, if you do res divide by 10, you get a 1, then calculates carry and digit. Right, so this is the carry. We're going to divide if it's, I was thinking the other way, I was thinking 20 minus, but that's what you do, you divide it by 10. Because then if you get 17, you get 1. If you're in that area, you get 1. And then the digit, you do the modulus of 10 because 10 modulus 10 is 0. 9 modulus 10 is 1, 2, 3. Right? Would it be like 6 modulus 10? 6, yeah. Huh? Yeah, 6 modulus 10. 5 modulus 10. I thought it was a remainder. I thought it would be 4, but okay. Interesting. Damn, that was a really long problem. Alright. We're going to end it there. Being on for about an hour and a half, so I appreciate you guys watching. I will see you tomorrow.